Hey guys, this is Mr. Gelming. These will be the last videos of the year. Kind of a weird way to end the year, but we'll get through these. We have two videos, two Edpuzzle videos, and then one Alex assignment, and that's it. Make sure you're checking your progress book, and we'll get started here. So here's a question from Alex that we're doing on here so you know how to do it. This is just statistics that we need to discuss. We haven't talked about a lot. So question A, first one here. Oops, sorry. Question A says, okay, it won't let me write. Okay, sorry. Here are the prices in thousands for 9 houses for sale in a local neighborhood. So when it says $157, it says in thousands right here. Oops. So that means $157,000, $285,000, $287,000, $288,000, $290,000, $292,000, $296,000, $302,000, $312,000. Which measure should be used to summarize the data? Well, anytime we summarize data, we think back to mean, and now this is multiple choice, but our choices really are mean, median, mode, or range. We need to summarize the data. We don't want to name all 9 prices of the houses. We just want to which measure would best describe it, would best summarize it. So typically with this, we'd be looking at mean or median. Okay, just the way that the question is phrased. And what we determine is this number 157,000 is called an outlier. An outlier is a piece of data that is outside all of the other data. It's not close to it. Now, the other data, 285,000 to 312,000, are next smallest to the next biggest. That's $27,000 separating them. But the other one, 157,000 to 285, well, that's like $130,000 separating them. That's a huge difference between all the other prices. If it ever has an outlier in the data, you always want to use the median. It's the best way to describe it. If we added these up and divided them by 9, the average would be really low. It'd be like, maybe even below 285,000, and that's not a good summary of the data. So in this situation, when there is an outlier, a number that's not close to the other numbers, doesn't matter how big or small, we always use the median. Okay, so on this problem, we'd want to use the median. Letter B, next one. On a test, each student is given grades of A, B, C, D, or an F. Which measure tells the grade given most often? Well, most often, you might remember that mode is the most frequent, or the number that occurs the most often. In this case, it's not a number, it's a letter or a grade, but it's the one that occurs the most. So anytime they want to know, hey, which one would be the best to tell the most often, those are always mode. No matter the type of question, that would be a mode question. And letter C, the next one. In the past 9 days, Felipe has received the following number of email advertisements per day. So this is similar to question A, and the numbers are 42, 43, 45, 46, 47, 48, 49, 50, and 52. Which measure would best summarize the data? Well, again, we're really down to median and mean. Okay, that's how we'd want to summarize the data. And the answer is there's no outlier on this. All the data is between 42 and 52. It's 10 numbers apart. They're all really close. 42, 43, 45. They're very close to each other. There is no outlier. So when there is no outlier, you always want to use the mean, the average. What you would do is add them all up and divide them by 9, and that would give you the average number of email advertisements that he receives per day. So no outlier is mean. If it is an outlier, it's median. Okay? So let's look at the next type of question. Okay, this one's pretty similar. Question A, The following number of people attended the last 9 screenings of a movie: 197, 198, 199, 200, 205, 206, 209, 210, and 292. Which measure would best summarize the data? Well, again, this 292 is not close to the other ones. It is an outlier. And anytime we have an outlier, we use the median. Why? If we crossed off the numbers, the 292 wouldn't make a difference. It wouldn't affect it at all, and our median would be 205, which is a good description of that data. Okay? About 205 people attended the movies. It's a good number. Very close to 197, very close to 210. Just 292 throws it off. Letter B is a part of the U.S. Census. The number of children is reported for each family in the U.S. There's a 2020 U.S. Census right now. Which measure gives the most common number of children for a U.S. family? Again, definition of mode: most frequent, most common. Anytime they're asking you for the most common number or most frequent number, that's a mode question. Those should be easy to spot. The last 10 calls to a customer support line had the following length in minutes: 22, 23, 24, 25, 26, 27, 28, 29, 30, and 31. Which measure should be used to summarize the data? Again, there are no frequency, so mode would be out. So we're between median and mean. And again, there is no outlier. It's always a mean. It's average. We'd add all those up, divide it by 9, or 10, excuse me. There were 10 calls, and that would give us the mean. It's the best choice for the data. Let's look at another problem. We have 2 more. So this one, Jose wants to find the average time it takes Washington High School students to run a lap around the track. So he will consider a sample of students to find the average time. Answer the question below. So which units could be used for the unit of measure? The unit of measure is measuring how long it takes the Washington High School students to run around the track. Check all that apply. So if you're measuring this, you would want to use time. Okay, if they wanted you to measure a cake, you'd use a weight: pounds, kilograms, grams, something along those lines. In this, we're running how long it takes to run around the track. So we need a time. Hours is a time. Seconds is a time. Minutes are a time. Okay? Hours probably aren't the best option here, but all 3 of those could be used for a unit of measure. Okay? Seconds or minutes would be best, but those are all times, so you could use all 3 of those. Letter B, this one here. Which of the procedures below would be the best way to find the average time? Okay, so this means how would we collect the data? So the first one says randomly pick 6 students to run a lap around the track and have them state their own times. First of all, the beginning of this randomly picking is smart. That's a good way to get accurate data. You don't want to go to the track team and have the 6 fastest people run it, because that's not a good representation of the whole school. You want to get random people, just like it says. The next one, randomly pick 40 students to run around the track and measure their times. Okay. And then on the first one, and have them state their own times. That means they measure their own time. That's not really a good choice. You really want to measure the time for them, and not them doing the measuring. That way you know it can be accurate and people don't give inaccurate information. So the second one, randomly pick 40 students to run a lap around the track and measure their times. That means we're measuring. So that part's better. The other part that's better, the bigger your sample size, the more accurate your data is going to be. If you only pick 6 students, you might get lucky or unlucky and get all fast kids or all slow kids or something along that line. If you get 40, you're going to get a random number of boys and girls and fast and slow in different times, and that's good. You want more. So the next one, measure the times of 6 volunteers who run the lap around the track. Again, only 6, not a good choice. So the 2 6s are out because you want more data. Ask for 40 volunteers. Again, if you're asking for a volunteer, you might get people that like running to do it. If you want to know find the average time it takes Washington High School students to run a lap, you want to randomly pick them. You don't want volunteers because they might have an affinity for running, or they might like it more. Okay, and then have them state their own times. No, you don't want that. So the one that works best, it would definitely be out of these two, 40 and 40, but you don't want to ask for volunteers. You want to randomly pick 40, just however, first 40 that walk in the door, whatever, walk around, whatever. But it has to be random, and you measure their times. Okay, I'll try to do this fourth one quick, hopefully. Maya, I think, and Joe want to find their mean number of students in their class this year. They want to find their average. So they randomly select students in their class and ask for the numbers. The results are shown below. Use the data to answer the questions. Here's Mia's sample, 17, 15, 10, 9, 11, and 5. And here's Joe's sample, 5, 8, 20, 16, 12, 19, and 15. Letter A. What is the sample size for Mia's sample? Or May's. I'm not sure how to say that. Anyhow, the sample size is how many pieces of data. 17 is 1, 15 is 1, that's 2, 10 is 3, 9 is 4, 11 is 5, and 5 is 6. So there's 1, 2, 3, 4. There's 6 is the sample size. Just how many pieces of data. Joe had 5, 8, 20, 16, 12, 19, and 15. 1, 2, 3, 4, 5, 6, 7. Joe has 7. Okay, so that's A and B. Very, very simple. Letter C, suppose you had to choose one sample to estimate the mean. Which sample is more likely to give a good estimate of the mean? Well, they're both very close, but again, like we talked about last time, the more samples you have, the more accurate it's going to be. So in this case, Joe's sample would be a little more accurate, even though it only has one more. Why? It's not because it has a smaller sample size. It's because it has a larger sample size. Okay? So that's all you would look at. We didn't calculate the mean, so we don't know what that is. You could. But if it has a larger sample size, it's more accurate. That's what you want. So that's all we're looking at for there. Sorry for the long video, 12 minutes. Sorry. Hopefully this makes sense. If you have questions, let me know. That's it.